Did you know that without this device, it's quite impossible to watch YouTube videos, stream Netflix movie, and send messages on WhatsApp? It is not that computers won't exist, but they won't be as fast, compatible, and efficient as they are today. A calculation which took ENIAC computer, which was the first programmable general-purpose digital computer, hours to calculate. It only takes smartphones of nowadays less than a second to calculate, thanks to this device called the transistor, a device that opened our eyes to digital world. The early computers, such as the ENIAC, use vacuum tube. Vacuum tube is made of three components: the anode, cathode, and the grid. If we supply an electrical current to the cathode, it will emit electron, and this process is called thermonic emission. Electron emitted by the cathode will be attracted by the anode of the vacuum tube. We can complete the circuit by supplying positive voltage to the grid, and we can turn off the vacuum tube by supplying negative voltage to the grid. There were about 18,000 vacuum tubes in the ENIAC computer. The ENIAC computer weighs about 30 tons and it covers an entire room. The ENIAC computer also consumes lots of electricity, while the modern computers can run on batteries. This device called transistor is used in modern computer. This kind of device is called the Metal-Oxide-Semiconductor field effect transistor, MOSFET. MOSFET is made of semiconductors such as silicon. Silicon cannot conduct electricity such as normal conductor, but can conduct electricity more than insulator. In an atom of a silicon has 4 valence electrons in its outermost shell. To complete the octet structure, a silicon atom makes covalent bond with neighboring silicon atom. To use a silicon to make a transistor, if we dope phosphorus atom, which has 5 valence electrons in its outermost shell, into the silicon structure, we have more free mobile electrons. This is called the n-type or negative type doping. If we dope boron atom, which has 3 valence electrons in its outermost shell, to another silicon structure, there would be one space to be occupied by an electron, so electrons will have spaces to move. This is called the p-type or positive type doping. If we join the p-type and the n-type doping together, some electrons from the n-type will migrate to the p-type and recombine with the holes in the p-type. This will create depletion region. A depletion region is where there is no free mobile electron. Like this, we've created a diode. Diode is a device that allows electrons to move in a single direction to connect negative side of the battery to the p-type and the positive side of the battery to the n-type. The positive side of the battery will attract electrons from the n-type to the p-type. This is called forward bias. If we change the polarity of the battery, the negative side of the battery is now connected to the n-type, and the positive side of the battery is now connected to the p-type. The negative side of the battery will repel electrons. This is called reverse bias. In this way, electrons will not move through the battery. To have a transistor, we need to add n-type doping to the other side. So if we have a structure like this, we've created a MOSFET transistor. But if we try to connect a battery to it, electrons will not move through the battery. To solve the problem, we need to add a metal layer with an oxide layer to the p-type. This is the gate of the transistor. If we add enough voltage to this side of the transistor, that is enough to attract the electrons to itself. Some electrons will recombine with the holes at the top, and some electrons will move to the top. By this way, we've generated another depletion region. With this structure, electrons will move through the transistor to the battery and back into the transistor. MOSFETs are interconnected to form logic gates, and the logic gates are combined to form the processing units that perform logical and arithmetical operations.